Okay, let's see question number 6 from October 2023 P3 paper. So what they have asked in question number 6. So before starting, question number 6 is basically from logarithms and exponential. Earlier we already saw a question from the same paper. Now again from the same part there's we can see another question number 6. Okay, so what they have asked in question number 6, let's see. Okay, an area of sea floor is being monitored. Okay, the area of sea floor S kilometer squared covered by coral reefs is modeled by the equation S equals to PQ to the power R, where P and Q are constants and T is the number of years after monitoring began. Okay, given that log base 10s equals to 4.5 minus 0.006 t. Okay, find according to the model the area of the sea floor covered by coral reefs with when t equals to 2. So when t equals to 2, we need to find out the area, that is the value for s. So just put t equals to 2 into the equation. So what you will get, log base 10 s equals to 4.5 minus 0.006 times 2. So that would give 4.488. Okay, so the value for s, the area covered, this is 10 to the power of 4.488. so you will get a very large number, that is 30,761. the area is in, I think, kilometer squared. Okay, so that means that much kilometer squared. That's the answer. Okay, for part B, we need to find out, find a complete equation for the model in the form s equals to pq to the power t. We need to give pq to 3sf. Okay, fine. So just we need to convert this logarithmic equation into its exponential form. That's it. So log 10 base 10 s equals to 4.5 minus what? Minus 0.006 t. So from there make s the subject. So s equals to, we know that log a n, if log a n equals to x, then a to the power x equals to n. We will use this concept here. So log a n equals to x, this is whole x, base is a. So that means s would be equals to what? 10 to the power 4.5 minus 0.006 t. Now just you need to simplify them, as equals to what? 10 to the power 4.5 times what? 10 to the power negative 0.006 t. So what would be the value for s? S equals to, we need to keep it in the form pq to the power t. Okay, so 10 to the power 4.5, 10 to the power 4.5, we need to give the values to how many decimal places? 3sf. Okay, so that would be, the actual value is 31,622.7766 times what? 10 to the power negative 0.006. This is 0.9 8 6 2 7 something like that to the power t. So now we need to give it to just 3 significant figure. So the value for s would be 31,600 times 0.986 to the power t. That's the equation for s. So we got the value for p. This is up to 3 significant figure, 31,600, and the value for q, it is what? 0.986 up to 3 significant figures. Okay. Next, part C. For part C, with reference to the model, interpret the value of the constant q. What does the constant q represent in this context? Okay. So q, we got the value for q, this is 0.986. Okay, what does it represent? If you see 31,600, okay, if you consider t equals to 1, it is 0.986. If you consider t equals to 2, it will be 0.986 squared. That means for the value of t represents the time in years. So after each year, the constant p is remaining constant. This constant p, the constant p, it is just remaining as it is. But after each year, like if t equals to 1, if t equals to 2, if t equals to 3, after each year, the constant p, it is getting multiplied by 0.986, right? So that means 0.986, it is the rate at which the amount of area covered by the coral reefs, it is increasing. So what we can say, 0.986, it is what? For part C, we can say this as the value for, we need to interpret the value of constant q. Okay. So the value of q, it represents what? We need to interpret, okay, for for 1 year change in for 1 year increase in time the amount of area, covered by the coral reefs increases by how much times? Increases by 0.986 times. This is the value for q, 86 times, and that's what the interpretation for the value of q. And that's all about question number 6.